Fatty acids can be characterized based on how many carbon-carbon double bonds they have. So we have 3 different categories of fatty acids. We have saturated fatty acids. Now you might be wondering if this has something to do with saturated fats, like when we're talking in terms of nutrition. Saturated fats and unsaturated fats, and they are kind of related to each other, but saturated fatty acids are not the same thing as saturated fats that you learn about in nutrition. When we do talk about triacylglycerols, which is coming up soon, that's when we're going to learn about saturated fats and unsaturated fats. A saturated fatty acid is one that has only carbon-carbon single bonds. So it's not going to have any carbon-carbon double bonds in it. It still does have the carbon-oxygen double bond because that's a characteristic of a fatty acid. So all fatty acids are going to have the carbon-oxygen double bond. But a saturated fatty acid will only have carbon-carbon single bonds, and that's like lauric acid. All of the carbon-carbon bonds are single bonds. So it is an example of a saturated fatty acid. If there is a double bond present, then we will describe the fatty acid as monounsaturated or polyunsaturated. So monounsaturated or polyunsaturated. Mono is the prefix for one, and poly is the prefix that means many. Unsaturated means double bonds. So a monounsaturated fatty acid has one from the mono part and one carbon-carbon double bond from the unsaturated part of the name. So one carbon-carbon double bond in the molecule, and we call it monounsaturated. And then poly, which means many, this means many double bonds. So 2 or more, 2 is many. 2 or more carbon-carbon double bonds in the molecule gets it classified as polyunsaturated. When we're looking at an unsaturated fatty acid, I'm just going to draw a few carbons here. You don't have to worry really about how many I'm drawing. I'm just going to draw a few carbons right there, and I'm going to make this one unsaturated. So we'll stick a double bond here, and I'll put a couple double bonds in there. We'll put a few. So this one's polyunsaturated. Because it has 3 carbon-carbon double bonds in it. And when we're looking at a mono or polyunsaturated fatty acid, we can also give it, it's not a name, but a designation, which we call an omega designation. And this designation is based on the location of the first carbon-carbon double bond in the molecule. The trick with this omega classification or designation is that you count or look for the double bond from the end of the carboxylic acid or the fatty acid instead of from the beginning. So when you first learned about carboxylic acids and that carboxylic acid functional group, you were always taught to start over at the carboxylic acid and count away from the carboxylic acid. And that is the standard notation. In this omega designation, we're going to start at the end and count our way towards the beginning. Now, if that has you feeling kind of confused and maybe irritated, it might be helpful for you to know that omega is a Greek letter and it is their last letter of the alphabet. So it's like saying Z in the English alphabet. So when you are counting something using an omega or giving it an omega designation, you are counting from the end of the molecule. That's what the omega means. So if we are looking to give this particular fatty acid and omega designation, we are going to count the carbon atoms starting at the end because it's omega. And the carbon atom where the double bond starts, which in this case is carbon number 6, that is the omega designation of that particular fatty acid. So we would say that this fatty acid here is an omega 6. So 6 means the location of the first carbon-carbon double bond, counting from the end. And it does not matter how many carbon-carbon double bonds are in the molecule. We are only going to list the position of the first. So this particular fatty acid is an omega 6, and if I were to erase some of these double bonds, it would still be an omega 6 fatty acid. If I were to give it some more double bonds, like lots of double bonds, it's still an omega 6. It's always the location of the first carbon-carbon double bond, and it does not matter how many you have. The double bond, the carbon-carbon double bond in a mono or poly unsaturated fatty acid could be either cis or trans. The carbon-carbon double bond can be either cis or trans. As a reminder, the cis double bond is going to have a shape that looks like this, whereas the trans double bond will have a shape that looks like that. So we're looking at the shape of the carbon chain across that double bond. We do know that, just from observation, that naturally synthesized, so naturally made fatty acids are usually cis. That's just how Mother Nature prefers to make them. And the last thing that I want to talk about with regards to fatty acids are the essential fatty acids. The word essential, so a word that has pretty heavy meaning in nutrition and also in some aspects of biology. An essential fatty acid, or we're going to learn about some other essential things as well, just simply means that it is needed by humans. So it's something that we need to survive, but we can't make it inside of our bodies. So it can't be made in our bodies. It can be made in other biological systems, like it could be made in plants, but we can't make it. And because we need it and we can't make it, it is an essential part of our diet. And this isn't really something that any of us have to worry about if, as long as we're not experiencing starvation. Just a normal diet, even a poor diet, we are going to get enough of these essential fatty acids. The essential fatty acids for us are linoleic acid and also linolenic acid. And if you look back up at what those are, linoleic and linolenic, they are the acids that are in corn and soy, which are a huge part of our diet. So we get plenty of those, and we don't have to worry about being deficient with either one of those.